Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. I want to send a quick thanks to our friends at Cloudera for their sponsorship of this series of podcasts from the Strata Data conference, which they present along with O'Reilly Media. Cloudera has long been a supporter of the podcast. In fact, they sponsored the very first episode of TWiML Talk back in 2016. Since that time, Cloudera has continued to invest in and build out its platform, which already securely hosts huge volumes of enterprise data, to provide enterprise customers with a modern environment for machine learning and analytics that works both in the cloud as well as in the data center. In addition, Cloudera Fast Forward Labs provides research and expert guidance that helps enterprises understand the realities of building with AI technologies without needing to hire an in-house research team. To learn more about what the company is up to and how they can help, visit Cloudera's Machine Learning Resource Center at cloudera.com/ml. I'd also like to send a huge thanks to LinkedIn for their continued support and sponsorship of the show. Now that I've had a chance to interview several of the folks on LinkedIn's data science and engineering teams, it's really put into context the complexity and scale of the problems that they get to work on in their efforts to create enhanced economic opportunities for every member of the global workforce. AI and machine learning are integral aspects of almost every product that LinkedIn builds for its members and customers, and their massive, highly structured data set gives their data scientists and researchers the ability to conduct applied research to improve member experiences. To learn more about the work of LinkedIn Engineering, please visit engineering.linkedin.com/blog. All right, everyone, I am on the line with Burcu Baran. Burcu is a senior data scientist at LinkedIn. Burcu, welcome to This Week in Machine Learning and AI.
Thank you very much. Thanks for having me.
Absolutely. So you gave a presentation at Strata. Was it yesterday?
Yes, it was yesterday afternoon.
And you were actually part of a group of folks at LinkedIn talking about using the full spectrum of data science to drive business decisions. And so we'll dig into that topic in a lot more detail. But before we do, how did you get started working in data science and machine learning?
So I work as a data scientist with the data mining team at LinkedIn. But actually, I am a mathematician. So I did my PhD in math, in number theory and algebraic geometry, which actually is a pure math, nothing to do with the applied math, like we just prove theorems and stuff. And then after my PhD...
I still have nightmares of real analysis in grad school.
Oh.
And that was probably your favorite topic.
Actually, I don't like real analysis also. I like more kind of linear algebra kind of stuff.
Okay.
So, real analysis. I can understand your pain though. So I did my PhD in Europe, and then I came to US as a postdoc in math, first at Stanford Math Department. I was there for 2 years, and then I went to University of Michigan, and again I stayed there another 2 years. So, but I was still, I was still thinking about being a mathematician. Like I didn't have any idea about, going in industry, being data scientist, etc. But during my time at Stanford Math Department, I had some friends in this area who are working.
You make it sound like prison during your time.
This was 5-7 years ago, I think. Yeah.
Okay.
So during that time, I had some friends, and they were, very much into this machine learning techniques. And whenever they have this math problem related to their machine learning problem, they were bringing to me. And that's where I started to understand how machine learning works, but only the math side of it, of course. And then during my time in Michigan, I was really very much into this machine learning. I started to think more about that. I slowly, moved toward this applied side of math. By using math, you can also solve that kind of interesting problems. And then I decided to, one day actually, I decided that I will quit math and then I will go into machine learning. But saying that, of course, it's not that easy. Like having all this theoretical math background, no coding or nothing, no statistical knowledge, just knowing the math. Like you cannot just go and do machine learning. I came to this area again. I talked to my friends and I asked them like, what else I should learn then. And then I realized this transition will not be that easy. But then I was lucky that at that time I heard about this Insight Data Science Fellow program. So this program helps people who has PhD in quantitative sciences to do the transition into data science. So I was accepted to that program luckily, and they helped me actually to do the transition. So they helped me to build the network and like learn the right stuff, and then have some data science project, and then start to talk to companies about being data scientists, going into interview and stuff. And my first job was at a startup, it is 6 Sense, which is located in San Francisco. They are just B2B intelligence company. So we were doing a lot of machine learning there. Actually, like I mean, I had learned about the theory of machine learning, but of course, like applying it, like coding and then getting the results with the real data is completely different. So this is like where I really learned how to do machine learning. And then after 2 years working there, 3 years ago I started to work at LinkedIn, and since then I'm working with the data mining team at LinkedIn.
Okay, awesome. Yeah, I've had a number of folks from that went through the Insight program on the show. I've also interviewed, I think Ross Fadley, is that his name? Out of New York. And I know Emmanuel, who runs the AI program or track out of the Bay Area. But I've had a bunch of really great conversations with folks affiliated with Insight in one capacity or another. Seems like a great program for folks that are kind of finishing, transitioning from academia to, either data science or machine learning, or they've got a bunch of other projects now or programs now.
Yeah, exactly. So actually, when I was in this Insight, they were pretty new. It was I was their second group actually. Like this was
wow.
4 years ago. Yeah. And now they are pretty big actually. Like they have a lot of programs going on. Yeah.
So maybe before we dive into kind of your session and data mining, I'm curious about this transition from kind of theoretical mathematician to data scientist. Do you use any of the theoretical math? Does it kind of impact at all the way you think about data science, or not really?
Oh, honestly, the math that I learned at the PhD level, I don't use that at all. Like, no, unfortunately, I wish I could use, but no, because I really spent a lot of time to, understand those concepts. But of course, like being in math, like having math education for almost 15, 16 years and being in math professionally for 10 years, of course, it has a lot of effect on how I do data science. So obviously, like I'm used to have this analytic thinking kind of thing. So when I have the problem, I can put a structure on it and I can see the big picture, and then I can try to solve it. And also, I all the time do this reasoning thing because I'm used to prove theorems, just combine all these logics. If this is this, then this is that. So this also helped me to think not only about hows, but I also care about why. So that helps me to have deeper understanding about the problem and also about their solution. And also, of course, I'm very comfortable with the mathematical concept. And actually, I have a story. So this was my interview with the startup. This is my first job as a data scientist. So there was this lead data scientist there, and he was interviewing me about machine learning techniques. And in the first half of the interview, he started to ask me about questions about those machine learning algorithms, and he was always asking me why you do this, why you do that, and I was so comfortable to explain those. I was comfortable with teaching. I was comfortable with the math concepts, and I was like, wow, I'm really rocking this interview. Like I know everything. And then okay, first half was great, and then in the second half, he said, okay, you know all these algorithms well. Now let's go to the easy part. He said, now I want you to implement this, algorithm on the whiteboard. I was like, oops, that's not that easy for me. And yeah, and I explained to him like, yeah, you think it's easy, but it's not easy for me. And actually, it took a lot of time, like to implement this on the whiteboard. And then he explained to me that he said that, yeah, I can understand that you don't have any coding experience, because I had just taught myself how to code, so it was not really easy for me just to do it especially on the interviews. And but he said that the direction that you come from is completely different. Usually people learns about these algorithms, how they work, how to code, and then maybe they dig into the math of those. So you are completely coming from different directions. So you have a deeper understanding of how they work, but now you also have to understand, how to write the code and stuff. So, and this is true. Like, this is helping. Now I'm much more comfortable with the coding, obviously. But having this deeper understanding of all these mathematical concepts behind those algorithms is really helping me a lot. Because when you do the modeling, there's always some problem. So if you know where the problem comes from, you save a lot of time actually. Otherwise, it's really hard to debug everything and then try to find out what's going on. Yeah.
So the session that you did at Strata was called "Using the Full Spectrum of Data Science to Drive Business Decisions." Yeah. Let's just kind of pick that apart. Let's start with full spectrum. When you talk about full spectrum of data science, what are you referring to? And it almost implies that you think that at a lot of places people don't use the full spectrum of data science. Maybe what are you getting at with that?
So with the full spectrum, we are talking about the whole process. Actually, we talk about how we do this production modeling, like the whole machine learning process, not only just the algorithm part, but we start from the problem definition part, how we clearly, when the business people bring us the problem, how we clearly define the problem so that we can convert into the mathematical problem so that we can solve it. And once we have the problem, we have the full definition, then we have to think about the data that we have. So for example, the label, if this will be the supervised learning, the label preparation is very important. So every business problem has different way of preparing the label. So we should be very careful about this label preparation. And once we have the label preparation, then we have to think about the features. So and when you have the features, how do you integrate with the labels? Like, how do you do the alignment on the timeline? And you had the static features, dynamic features. How would you combine those static and dynamic features? And once you settle all those, then we start with the modeling techniques like training, and we talk about the data partitioning, and we talk about the common mistakes that first we did, and then now we have a lesson so that we don't do it anymore. And then after the training, we talk about the model deployment. So how do we give our results to our business partners? And the most important part, and actually the most challenging part, is when you give the results to your business partners. When you solve the problem, it's not finished yet. So because they use this solution over and over again, so you have to check if the features are or the models is doing good. So because you have the results the first day, everybody's confident about the results, model is fresh, it's perfect. But after 30 days, oops, something going on, the red flag. So what's going on now? So we have to monitor the features, we have to monitor the model performance, and we have to just run basic statistics about is everything stable or there's some degradation somewhere. And once you do this, maybe you might decide to do model refresh. And when you do the model refresh, you need to do the A/B testing with the current model, and then decide which model to release. But sometimes it's not the model the problem, where the problem is. Sometimes it is the feature logic is different. So for example, let's say you are, one of the feature is the checking the traffic of your web page, let's say. And let's say your web page is just one page web page, but after a month it has just 3 pages. But then checking the traffic of the first page is now changed the meaning. So you should be aware of those kind of changes if it is there. So because you need to be aware of the content, if you are giving the right content to your machine learning model or not. So we talk about whole this process and each steps like in detail, and then we also talk about some common pitfalls and challenges that we have during this process. Like, for example, model interpretation is one of the biggest challenges that we have here, because when we present our results to the business partners, they don't only care about the results, they also care about why we get these results. What are the key drivers? So it's pretty challenge to find, especially when you have the more complex models. It's getting harder to explain what's going on. So you cannot just use models as a black box for those kind of problems. It's also data quality is very important, and it's another challenge. The more data is much harder to maintain the quality of the data. So yeah, we talk about whole this process by giving examples and the things that we need to careful about. But this was the whole, like, how we use a whole spectrum of data science to give business decisions.
Well, that's a lot of. I think there are like now I understand why there are like 5 or 6 people presenting this.
Yeah, exactly.
This was it a full day tutorial or a half day or something?
3 hours actually.
3 hours? Okay.
Yeah. Slides will be online soon, so yeah.
Okay. Oh, cool. So let's maybe walk through some of these points. You started at the beginning, right? Problem formulation. A lot of people, we talk a lot about algorithms, but that initial, phase of really understanding the problem that you're trying to solve and translating that into, kind of mathematical or data science thinking can be a challenge. How do you approach that? And, what have you learned? What do you think that people get wrong about that?
Actually, what I learned is that the domain knowledge is very important. So it's not only the business partner can make it like a good problem to solve, or it's not only the data scientist who can just make it into math problem and then start solving it. It's the conversation is very important. So data scientists should really understand what is really the business partners trying to solve, what is the background, where this problem is coming from, and then once the data scientists understand this, then she needs to convert this into mathematical problem, but then she needs to explain like how she views it, like where the solution is going. Is the solution that she's trying to go, is the direction is the same as the business partners thinking about? I think the conversation is really very important. When data scientist tries to convert this problem into mathematical problem, she needs to understand the domain knowledge from the business partner. So, for example, I will give a very easy example. So let's say LinkedIn Talent has this product called career subscription. So it's usually the people who are job seeker buy this product. It's more about you can view the third degree connections profile, and you can do advanced job search, etc. So let's say LinkedIn Talent wants to make an email campaign for the product career subscription, and they want to send email for this. And how do they send? Who they should send those emails? Basically, this is the question that they bring up to us. So obviously, for example, they cannot send it to all like 610 million members. So we would have another problem if they would do that. So they bring this problem to us, and now we start to ask this question: oh, do we also have historical data about this? Did you already sell this product before? So if you sell this product before, can we get the data? So are these people the LinkedIn member? Can we get more data about those people? Once we are able to get the answer for this, then we say, okay, we have the data, then we can solve this problem. We can just apply machine learning techniques and then get the solution and then give the results. But then they say, okay, I don't only care about who will who I'm going to send these emails, but I also care about why I send these emails to these people. Then you said, oops, then they want the model interpretation also. So then the problem is different. So I don't only care the performance of the model, I also care about the interpretation of the model. So when I'm doing the modeling, I need to balance between the performance and also interpretation, because with our experience, models like random forest, XGBoost are performs much better than the logistic regression, linear regression, those kind of models. But these kind of it's hard to use it's hard to do the model interpretation with the random forest. Of course, there are this feature importance coming from these machine learning techniques, but we should be careful about the bias coming from them also. So it's hard to use them as a black box. So we try to use much simpler model, maybe sacrifice some of the performance of the model. So yeah, those are the things, like, they tell us the problem and then we think about the mathematical solution, but then we drive the conversation from there on and then try to find solution together, basically.
And is this a process that you're usually able to, you have an hour meeting scheduled and they come to you and tell you their problem and you're all on the same page by the end of that meeting? Or is it a process that, continues for an extended period of time?
Actually, yeah. So it's usually like my team is more like how to say, like horizontal team. So for example, LinkedIn Talent has own data science team, so they are in conversation with their data science team. So this data science team already helped them to convert this problem into mathematical problems, and this team is aware of all the data, everything that they have, so they are in contact with them all the time, basically. Okay. So this is a vertical data science team. I am more horizontal data science team. We are more technical. So when their data science team have this machine learning problem, and if it is a little bit more complicated than they expect, then they bring this problem to our team, and then we try to solve this together with their data science team. So when we had the question, we usually contact with the data science team, but yeah, data science team is all the time in contact with the business partners. So they are aware what's going on their side. Yeah.
Do you often find that that folks are kind of going down, blind alleys, and you have to you engage with folks that are kind of far into the modeling process, but in order to actually make progress on what the business is trying to do, you have to kind of start all the way over from the definition of the product? Or does having kind of a data science team that you're working with kind of alleviate that issue? I guess I can find in conversations, with, folks that are in data science supporting, business units, that often the business units will come to them with kind of, wild, half, thought out, hey, I want a model that does this. And there's really this kind of walking back that you need to do to get them away from thinking about a specific solution to what the problem that they're actually trying to solve is. And I'm wondering how that manifests for you with the kind of two layers that you have to get back to the business itself.
Yeah, I mean, those things happen. So a few times it happened, for example, like the problem, the way that they converted didn't make sense. And we realized it when we started to check the data. So we realized that something is wrong, like it's not, maybe these are not the results that they expect. So, and then you start to slowly debug. Then on the process from problem formulation to getting the data, something must be broken there. Then we slowly debug, and a few times we realize that the problem preparation, there is a problem with the problem definition. Then we go back there all together, and we sit together, we try to understand, and we try to convert the problem together there. Yeah, it happened actually a few times.
And is there, you kind of talk about this debugging process. Is it, what is that process? Is there kind of a set way that you go about that, or is it kind of systematically, checking your various assumptions until you find something that doesn't line up?
So there is some parts that we do manually, and the other parts are done in the platform. So the ones that we do manually, we really check if we are doing it correctly or not. For example, the logic on the label preparation. So
Mm-hmm.
is it really the logic there is the right logic? And usually, like the models that I'm talking about, they are done like many times. But when you do it for the first time, then there might be a problem. So we are very careful about the problem. For example, on B2B business or even B2C, like acquiring a new customer or empowering a new customer, empowering an existing customer of like a churn model, we have done those models before. So we know we know the label logic, we know how to do the problem definition. But if the new problem comes and it's the first time that they have this problem, there we need to be careful. Like there, actually, you don't immediately put the definition and then start to solve. So this is ongoing process. You start to think about it, and then you maybe try one prototype model and discuss about the results, and you go back again. Like, okay, if I had changed the problem to this, then would I get the same result? So this is not in that sense, like it's not all the time. Like this debugging issue doesn't come very often, but we know actually when it can come. If the problem generation was the first time, then we might have this problem.
A lot of the issues that you described, you mentioned kind of this label preparation stage a couple of times. It seems like, especially when you start tackling a new business problem, it's one of the areas where technical or process problems tend to creep in. Can you talk a little bit about that label prep stage and the kinds of things you're doing there and the way you approach that at LinkedIn?
Yeah. So label preparation, for example, I will explain it with the example that I gave about this LinkedIn talent wants to do the email campaign about the product careers subscription. For example, they say that they have data. So the data is like they send this email before, and how do you prepare the label from that? So this question has a yes or no answer, right? It will be a binary classification. It will be either positive or negative. So, but how do you define the positive? How do you define the negative? For example, you send the email, and then what? What is positive there? Just reading the email, clicking the link that we sent, or buying the product. And what is the timeline that you're going to put? Like, if they buy, for example, you decided, okay, if they buy, it will be positive for me, this will be my label. Then are you going to wait for a day, for a week, for a month? So what's the timeline for this? You have to stop somewhere. So deciding those things are important. So again, you check the data when you are defining the label. So this is very important, actually, this label preparation part.
And the example you just gave, those are labels that you can acquire, define programmatically by, presumably running some, SQL queries against your data warehouse or something like that. Is that the majority of the types of problems that you tackle within the data mining domain? Or do you ever have kind of these problems where you have to go back and manually label a bunch of data?
Yeah, so the logic is done manually, but as you say, after you have this logic done, then you just write the code, and then code just runs on the Hadoop or like on HDFS, and then automatically we get the data. But the logic is the most important part. So once you have the logic, you discuss the logic, and you get the code review on the logic. If everybody agrees this is the right logic, then the code just goes on. We use the same code over and over for the same kind of problem.
Mm-hmm. And you mentioned kind of this issue of, in the talent example, kind of attribution. When do we say that someone's bought? And also, I frequently kind of hear about, issues around features with like point in time correctness and, the whole time machine thing. Is that something that comes up in the types of problems you're dealing with?
Yeah, those time alignment is really very important. So again, with the same example. So for example, let's say you will you will also look at the behavioral features of those people who you want to send the email, because it's important to check if they did recently a job search or if they had networking recently, for example, with the recruiter. So it's a really big indication that they might buy this product. But then the time is very important. So you have to put some time, and you are going to look at the action that they did before that time, right? But where do you put this time? Do you put it when you send the email, or like when they click the link, or when they did a subscription? Because after you send the email till to the point that they buy, if you look at the action, their behaviors during that time, that might be bias. That might be that they are just curious about the product, and they might, I don't know, wonder about something and go and check and do the search. So it might not be that they are planning to change their job or something. So maybe it's a good idea to check those, all this kind of behaviors before you send the email, before they become aware of this product. So deciding those kind of time, and then when you combine it with the label, the feature, and just putting the timeline on the correct place is also very important. And of course, these are more for dynamic features, like for snapshot features, like where they live, their job title, things like that, which doesn't change very often. These are not a big, huge problem, but the dynamic features are, one should be very careful about those.
So you've got your problem defined, you've got your labels generated, you've dealt with alignment issues around your features. Then it's time to, start modeling and training a model. What are some of the kind of gotchas that come up there?
Yeah, so the first thing is, of course, like partitioning the data, like training, validation, and testing. Of course, like the sizes depends on your data size, and but one thing that we are very careful. For example, if you had duplicates in your data, you should really immediately dedup all this kind of data, because let's say you have same data, and one goes to training set and the other goes to testing set. This is a problem.
Yeah, leakage.
Exactly. Then this is data leakage. You should be careful all those kind of things. And after the partition, then in the model training part, there are a few things that you have to be careful. For example, you have to check your system requirements. So do you really need very fast algorithm, or just your system is really you don't care about the speed of the algorithm? Also, I already talk about the performance via the interpretation of the model. Do you need the interpretation, or for you the performance is the most important one? Because here at LinkedIn, like, we usually sacrifice the performance of the model, like, because interpretation, for most of the problem, interpretation is really very important. But we also have other problems where, for example, interpretation doesn't have anything to do, so we really focus more on the performance.
I wonder, on that interpretability point, is that static for a given problem, or does it change? And I'm kind of envisioning where, a problem is new to a business. They don't really understand the data and the underlying behaviors. And so they want something really interpretable to help them build up an intuition. But then, over time, they start to get a better feel for, what they're trying to model, and maybe they're willing to, sacrifice some of that interpretability for additional performance. Is that a common trajectory?
Exactly. So this is very common, actually. So it happens a few times. For example, we propose them to send emails some certain customer, and they say, no, we shouldn't send this to this customer. Like, I'm pretty sure this is not the right one. But we say, but the model says, really, you should send an email to this one. So then they ask why. So those examples, we should be ready because of this and this. So, and if we use the algorithms as a black box, we can't answer those kind of questions. We say, sorry, the algorithm says this. So they say, no, I'm not going to send this email. So we should also convince our sales representatives, these people are really important, and these are the reasons that they are important. So actually, we have some in-house solution to that, because sometimes, like for example, the performance of the performance of the models, which has good interpretations, is really very low. We cannot use them, so we need to use like a good performer algorithms. So we have a solution for that, in-house solution. So, for example, let's say we have 300 features in our master model, and we model with all these 300 features, and we score, the customers, and then we try to predict if they will buy some certain product or not, and we want to know why they buy this product. So what we do is that we divide the features into different buckets, where each bucket has like semantic business meaning. Like, those features are like behavioral features, those features are social features, those features are identity features. And let's say I divide into 3 different buckets, and then I build a model with the features within each of these buckets. So I have like 3 different models apart from the master model that I have. And the important thing is that each of these models has their own semantic meaning. And in this way, I stop the correlation between the features, between the groups of the features, and this also reduces the noise. And for example, when I score with my master model each customer, I also score them with this we call them component model. I also score them with this 3 component models, which has different meaning. So for example, few times I realized that for example, certain person has a high score with the master model because they also have a high score coming from the behavioral feature model. On the other hand, somebody else, another customer, has the same thing for the social feature model. So this tells us that, okay, so the first one got a high score because of the behavioral features, and the other person got high score because of the social features. And this also helps us to send a personalized email. So when we are trying to sell the product to this person, for example, in the email, we talk about more like behavioral features. We say that, you can do that much more search with this product, actually. And we thought that person might be more interested on search. On the other hand, for the person who got high score because of the social features, we more talk about what kind of networking that person can do, if he buys this product. So this really helped us a lot, actually. So this is our in-house solution that we use. For now, up to now, it worked pretty well.
And so is this component model, are you using it strictly for kind of interpretability signal, or are you then like training some ensemble of these components and then using it to maybe replace the original model or supplement it in some way?
For now, we only use interpretive purposes. Few times, if the master model does not do good, but we see a very good performance coming from the component models, we try to combine. So because then we realize that there is really big noise, when all the features are together. So like the models behave much better when you separate the features from each other. But up to now, we couldn't see a good performance coming from combination of those models. So we just use them separately up to now.
Okay.
Yeah.
You earlier mentioned data partitioning, and there's kind of the usual test train split kind of issues there, but I imagine that you have to do things somewhat differently when you're working with 660 million, users, and you have graphs and things like that. Beyond the deduplication, are there, ways that you deal with data partitioning that are kind of unique to LinkedIn Scale?
Yeah. So, for example, a few times, since usually we collect the data in US, we should be careful about, for example, if we are using the geolocation as a feature. So it's usually it's US, but we have also a lot of data coming from Europe or Asia. So we should also be careful. So we also, in order to have the good representative of each feature, we also do like certified random sampling for each of the both training set, testing set, and validation set. So we are also careful that each feature is representative. Yeah, this is also something that we are very careful. Yeah, other than the duplication of the data.
Are you typically building models against all of the data, or are you, sampling and training on subsets?
We usually do random sampling
Just
and
random
train on
sample.
subset. Yeah,
Okay.
especially if we do the model on the member level. So we are trying to be careful about the timeline also. So for example, let's say if you wanna sell the product today, we look at the people who bought last year, and we only focus those members. We don't go and check every member. And then we do the model on those people who bought last year. But of course, in terms of scoring, then we use most of our members in order to score and then see who will get the highest score, who has the most probability to buy this product.
Mm-hmm. And is that the kind of locking in on a specific year? Is that because your distribution will have changed over time and you don't want to kind of confuse your model by pulling in users from a broad period of time?
Yeah, exactly. We just define a certain period of time. That time, like we send this email, did they buy in the next month or not? So we make this definition very clear, and then this will be our labels associated with the members. And then we start from there. Then we attach the features to those members. So, but the timeline is very clear. Yeah.
And so the next thing on your list was kind of sharing the results to business partners. Is this usually in the form of kind of a deployed model that's like a service that is integrated into some application, or is it more, like business intelligence reports and decision criteria, or what are the different ways that you both deploy and communicate results to the business?
Yeah, so we show our results on our testing set. Of course, we never touch the testing set during the training purposes or choosing hyperparameter or like an algorithm. So like we have a completely independent testing set, and we apply this testing set, the model that we choose. We think is the best performed model, and then these results we need to show some results to our business partners. So since this is business problems, we also consider the business metrics. So, for example, the conversion rate is very important for them. So we have to show them the conversion rate. So it's also they are interested in the ROC curve. So it's a little bit technical, but they have a way to see to compare two models, because when we present the model, probably there is another model coming from the last year. So this is our baseline model. So they will be able to compare. Oh, this model is doing good or bad than last year. Why is this so? So this is all, this will be all the discussion between the business people and us. So yeah, we prepare our, the performance evaluation. If it's a binary classification model, it will be probably ROC curve and the conversion rate. We also, of course, prepare the key drivers. We show them the key drivers, if they make sense to them or not. So because they have really good domain knowledge, so they can say, oh, this feature doesn't have anything to do with the results, why did this come up? And then we go over, for example, they want to see the people who has the highest scores, so we go over them and they check them. So and if they see any red flag or not, then they let us know. So we sit together for an hour and we discuss all those things, and they go over the companies which have the highest score, and then we get the feedback from them. And if the feedback is positive, then we release the model to them. Then the scoring process starts, and we can deploy our model.
Maybe we can kind of wrap things up with talking about how you ensure that these models remain fresh. You mentioned A/B testing is something that you do.
Yeah, yeah. So we use A/B testing in order to, if we need to refresh the model, then we use the A/B testing to see if the current model is better or the one that we built, if the new model that we built is doing good. But before that, once we have the model, we constantly do the feature monitoring and the model performance monitoring. We want to see the trends on the feature, if anything is decreasing or increasing, if there's any spike on the features, is it because of the I don't know, holiday season or something else going on? So we should be aware all those kind of things. Same thing with the model performance. There something might be broken somewhere, so it is really important to go and see if it's coming from the features or it's coming from the model. And then once we are aware of all those, then we might decide to refresh the model and do the A/B testing and decide to go with the current model or with a new model.
Yeah, this A/B testing, is it primarily offline A/B testing, or are you doing it online as well? And if you're doing it online, how do you ensure? I imagine at your scale, like ensuring kind of statistical significance probably isn't something that,
Yeah,
it happens probably pretty quickly.
yeah.
Maybe depending on the problem, but like, how do you address those kind of practical issues associated with A/B testing?
Yeah, from the customers, they just do the random sampling and then start to, start to use the results from both models. Like they get the
Hmm.
results from the existing models, they get the results from the new model, and then with these results, the sales representatives, they try to use both models, and the way we assign those results coming from the both models are really random. So sales representatives are not aware if they are using the current or the new model, and then we just compare the results, like if the results are coming same, or if there's any statistically significant level of confirmation that one should be able to use the new one.
Kind of any parting thoughts? We covered a lot of ground, and you certainly covered a lot of ground in your
Yeah.
presentation. Did you leave the audience with kind of key takeaways of things that they needed to be thinking about as they're implementing this in their own companies?
Yeah, so okay, so we talk about, each step of this machine learning process for the model, for production the model for business problems. But actually we can pack all those things which can serve not only to you but everybody in your team. So because if one person goes all of this process once, it's okay, but if everybody in your team does this over and over, then it's not really efficient. So we should build something which is better, smarter, and which can do this process, and it is doable. So there are some platforms who does this, so like AWS, Microsoft Azure, Google Cloud. You can consider to buy those platforms, being aware their limitations, their data source, the algorithms that they use, or one can build their own platform which will do this process. Or you can do something in the middle, like you can assemble both the existing platforms with your in-house solution. So one should consider what their problem is, their timeline, their budget, and then instead of going over this each of the step manually one by one, just make this a service, and then one can use this service over and over. But of course, one should be careful about the simplicity is the ultimate sophistication. So it is very important to make this platform as simple as possible, because it's important to maintain this platform. Also, simplicity is important for the user experience. But yeah, like instead of going this process one by one, just consider this as a service is the best way to look at it, I think.
Agreed. Awesome. Well, Burcu, thank you so much for walking me through all this. Sounds like a really great presentation, and I love the kind of closing imperative to think about how to make this process more efficiently by supporting it via some platform.
Thank you very much. It was really a pleasure to be here.
All right, everyone, that's our show for today. If you like what you've heard here, please do us a favor and tell your friends about the show. And if you haven't already hit the subscribe button yourself, make sure to do so you won't miss any of the great episodes we've got in store for you. For more information on any of the shows in our Strata Data series, visit twimlai.com/stratasf19. Thanks once again to Cloudera for sponsoring this series. Be sure to check them out at cloudera.com/ml. As always, thanks so much for listening, and catch you next time.